The phenomenon you're referring to is likely the ongoing geological activity along the East African Rift System, where the African continent is slowly splitting into two separate plates. This process is occurring along the East African Rift Valley, which stretches from the Afar Triple Junction in the northeast of the continent down through eastern Africa to Mozambique. Tectonic plates. The Earth's lithosphere, or outer shell, is divided into several tectonic plates that float on the semi-fluid asthenosphere beneath. The East African Rift is a divergent boundary, where the African plate is splitting into two smaller plates, the Somali Plate and the Nubian Plate. Rifting process. The rifting process is driven by tectonic forces that pull the plates apart. This causes the crust to thin and create a rift valley. As the plates move apart, magma can rise from below the Earth's surface, leading to volcanic activity and the formation of new crust. Geological activity. The region is characterized by volcanic activity, earthquakes, and the formation of faults and fissures. Notable features include the volcanic mountains of the Great Rift Valley, such as Mount Kilimanjaro and Mount Kenya. Future implications. Over millions of years, if the rifting continues, the East African Rift could eventually form a new ocean as the Somali Plate separates completely from the Nubian Plate. This would create a new coastline along the eastern edge of Africa. The East African Rift is a prime example of how tectonic processes shape the Earth's surface over geological timescales. It provides valuable insights into the dynamics of plate tectonics and the creation of new geological features. Certainly, let's delve deeper into the East African Rift System and the geological processes involved. Detailed geological processes. Beneath the Earth's crust, mantle plumes or upwellings of hot rock from the deep mantle can cause the crust above them to heat up and become more buoyant. In the case of the East African Rift, a mantle plume is believed to be contributing to the uplift and stretching of the crust. This plume is sometimes referred to as the Afar plume due to its location near the Afar Triangle. The rift system can be divided into two main branches, the Eastern Rift Valley and the Western Rift Valley. The Eastern Rift Valley, also known as the Gregory Rift, runs from the Afar Triangle through Ethiopia and Kenya to northern Tanzania. The Western Rift Valley, or Albertine Rift, runs from Uganda through the Great Lakes region of Africa, including Lakes Albert, Tanganyika, and Malawi. These rift valleys are characterized by a series of deep faults and large grabens, or down-dropped blocks of crust. The stretching of the crust in these areas leads to the formation of fault lines and fissures. The East African Rift is one of the most volcanically active regions on the planet. Volcanic eruptions occur as magma rises through the thinning crust. Notable volcanoes include Mount Nyiragongo and Mount Nyamuragira in the Democratic Republic of Congo, both of which are known for their highly fluid lava flows. The volcanic activity is not only a surface phenomenon, it also affects the geology beneath the surface. Magma chambers and dike intrusions can alter the structure and composition of the crust. Seismic activity is a common occurrence in the East African Rift region, primarily due to the movement of tectonic plates and the associated faulting. These earthquakes can vary in magnitude, but they often provide valuable data for understanding the rifting process and the dynamics of the Earth's crust. The rifting process is a slow but ongoing phenomenon. As the Nubian and Somali plates continue to diverge, the rift valley will eventually widen. Over millions of years, it is possible that the rift could evolve into a new ocean basin, with the Somali Plate becoming a separate landmass, creating a new oceanic crust in between. This process is similar to what happened to the Atlantic Ocean, which formed as the South American and African plates separated. Environmental and human impact. The East African Rift Valley has significantly shaped the landscape, creating a variety of ecosystems ranging from arid deserts to fertile highlands. The rift's lakes and rivers provide critical water resources for local communities and support diverse wildlife. The region's climate can be influenced by the topography created by the rifting process. For instance, the highlands can receive more rainfall compared to the low-lying areas. The rift region is densely populated, with major cities such as Addis Ababa, Nairobi, and Dar es Salaam located nearby. The geological activity poses both challenges and opportunities for development. Earthquakes and volcanic eruptions can threaten infrastructure and lives. But the rift also offers geothermal energy potential, which is being increasingly harnessed for electricity production. The East African Rift System is a dynamic and complex geological feature that provides a natural laboratory for studying tectonic processes, volcanic activity, and the evolution of continental rifting. Its ongoing activity continues to shape the physical landscape and influence the lives of millions of people in the region.